Macam tu, group yang pertama dah ready ke nak present?
Ya, doktor.
Okey, saya record kelas ni, nanti kita boleh refer balik. Alright, silakanlah group pertama present. What is the topic?
DME.
DME kan? Alright, silakan.
Okay, alright. So today we would like to present about polarography dropping mercury electrode, which is also called SDME. So for the introduction part, so for the outline, there is 5 outline lah. So the introduction part, what is DME? Okay. DME is a working electrode made of mercury and used in polarography. And basically, experiments to iron with mercury electrode is known as polarography. So, mercury continuously drops from a reservoir through a capillary tube. Dia punya diameter ni between 0.03 until 0.05 meter. Then mercury tu akan drop lah into the solution. Lepas tu optimum interval between drop tu mesti dah between 2 saat hingga 5 saat. And DME ni sama je macam like any other working electrode. Dia punya electrode ni used in electrochemical studies. Menggunakan theory electrode system when investigating reaction mechanism. Okay, next.
Okay. Dengar tak? Okay, for the history, in 1992, Herovsky discovered a technique with the help of which qualitative, quantitative, and even mixture can be analyzed qualitatively and quantitatively. The technique is known as polarography, which is DME used So this is the chemist, which named Jaroslav Perovsky was a hello.
Kenapa tu? Stop? Ada orang call ke apa?
Hello, sorry. Okay, Jaroslav Perovsky was a Czech chemist and inventor. Perovsky was the father of the electroanalytical method and recipient of the Nobel Prize in 1959 for his discovery and development of the polarography method of analysis.
Okay, next is construction. So the assembly consists of a mercury reservoir, and it consists of 5 capillary having bore size range from 20 to 50 micro and 10 to 50 centimeter long. So the capillary is connected with mercury reservoir by the rubber tubing, and a small glass electrolysis cell in which the unknown solution is placed. And the last one, the height of the mercury reservoir is adjusted, that dropping time is 1 to 5 seconds. Next. So for the working, mercury drop form at the end of the capillary delivery tube, grow with time to the certain size and then fall off. So the typical drop lifetime is 5 seconds. Next is the electrochemistry is done on the mercury drop, and the electrode is regenerated the following the loss of each droplet. So increasing potential is applied as the linear function with respect to time between the DME and the auxiliary electrode. So the scan time is usually on the order of 10 minutes for the typical voltage ramp range from 0 to 2000 megavolt. Next, Jessica.
Okay, next, the DME has advantage and disadvantage. So for the advantage is the surface area is reproducible, and mercury form amalgam, which is solid form with most metal, and each drop remains unaffected and does not become contaminated by the deposit metal, and the surface area can be calculated by the weight of the drop. And the disadvantage of the DME is the capillary is very small and it is easy to be blocked. And as we know, the mercury is most toxic chemical. And next, the surface area of each drop of mercury is not consistent. Okay, not constant. So lastly, the mercury cannot be used at higher positive potential because the oxidation of the mercury. Okay, next.
For the application part, this method can to analyze ions, which is very heavy metropolitans in water because it's highly sensitive to these metals. Other than that, we can use to track identify the trace metal in the. Besides that, the organic phosphorus pesticide residues also can be detected. Organic species that can undergo redox reactions, such as the reducing sugar or vitamins, also can use this method to be analyzed. And to analyze the generated in a polarigram. Polarigram is a graph of current versus the potential in polarographic analysis. From the polarigram, there are two main information that we need to analyze. This one is the ID, which is the diffusion current. It indicates the concentration of the substance. And for the half-wave potential, which is the E1/2, indicate the identity of the substance. So from here, we can see that got 5 terms for each polarigram. First will be the residual current starting from the zero. So the residual current is the small current before the potential at which the analyte reacts, caused by the reactive species and mercury drop behaving like a capacitor. When the voltage increase and the analytes start to detect by the current, you will see that here we will reach a limiting current. The limiting current is the maximum current that can be reached. And the half-wave potential, we just now we mentioned that the E half is the potential halfway up the polarographic wave, which is similar to the reduction or oxidation potential. And because it is very specific, so each of the analytes got their respective E half, which means we can use to identify the analyte using the E half. And for the diffusion current, which is the difference between the limiting and the residual, and it is proportional to the concentration of analyte. And here we can see here that there's a point indicated by this arrow is the decomposition potential, which means the minimal voltage between the anode and cathode that is needed for electrolysis to occur. So start from this point, the current will be increased here. fluorography measurements, we can see that the magnitude of the diffusion current, which just now we mentioned the ID, is given by the Electrode equation, which is the Kn d to the power of 1 over 3, m to the power of 2 over 3, e to the power of 1 over 6 c. The K, we got two values, one is 708 and one is 607. 708 is for the maximum current and 607 for the average current. D is the diffusion coefficient of the depolarizer in the medium. N is the number of electrons exchanged in the electrode. M is the mass flow rate of mercury through the capillary. P is the drop lifetime, and C is the depolarizer concentration. So that's all for.
Okay, thank you. You have any question for this group?
No, Doctor.
Yeah. Okay, teruskan pada next group. Nanti soalan kita kumpul lah. Soalan nanti boleh tanya saya ataupun boleh tanya semua ahli group lain.
Nampak ke slide?
Yes, nampak. Silakan.
Alright. Okay, so Assalamualaikum and a very good afternoon to Dr. and fellow classmates. Today, Group 2 will present about static mercury drop electrode SMDE. Okay.
Okay, so what is static mercury drop electrode? Okay, SMDE is an electrode in which successive drops of is an electrode in which successive drops of mercury form at the end of a capillary tube as the result of the mechanical plunger, with each drop providing a fresh electrode surface. Static mercury drop electrode can be functioned as both dropping mercury electrode and hanging mercury drop electrode. Kenapa dia boleh bertindak sebagai dua ni? Because kalau kita tengok dekat graf tu, DME dia punya size dia makin lama makin besar, and then dia drop. Okay, tapi kalau HMDE ni dia static je, dia punya size tu dia maintain je. Okay, that's why kalau tengok dekat dalam graf ni, kita ada part yang makin lama makin besar and then dia ada static. So menunjukkan yang sebenarnya static mercury drop electrode ni boleh bertindak sebagai DME dan juga HMDE. Dan juga it can be used to measure analytes with concentration of low ppm. Kalau compare dengan DME, dia boleh measure analyte at high ppm. Kalau untuk SMDE, low ppm. Dan dari segi uses dia digunakan dalam analysis of toxic metals in drinking water, elemental and functional group analysis, determination of herbicides and pesticide residue in food, and characterization of organic matter and metal interaction in marine study. Next.
Very good morning to all my friends and doctor. Now, I'm talking about instrumental parameter of SMDE. This is the picture of 3D for using the static mercury drop electrode. There are four parameters that we use, which is one, power supply by polarographic analyzer. The second one, the power consumption, we use 10 watts. And the reservoir capacity, we use 180 ml mercury. The last one, cable, we use the specific for each polarographic analyzer. Next. And then this is three effect on SMDE, which is electrode kinetic, potential drop, and mass transfer. Based on the previous slide, which Shafiq intro the graph, this will give the effect during the graph containing increase and then during the static and then drop at the reaction. Next.
Dengar tak? Dengar? Tak dengar? Dengar tak?
Dengar.
Okay. So, okay. For the history, first static drop mercury electrode was first invented by John L. Smith and Bruce N. Whitlock in 1981. So the diagram below is the first plan for the static mercury drop electrode. He claimed that static mercury drop electrode comprised a housing forming a reservoir for liquid mercury or other similar fluid. So then they patented their design of static dropping mercury electrode. After that, there is no have been done by using static drop mercury electrode. And then in 1922, maksudnya dah tersalah ni, tersalah apa? Dia punya kronologi. Okay. And then at first in 1922, Professor Gerard Herofsky carried out his pioneering experiment with dropping mercury electrode, from which polarography gradually evolved. And then in 1950, he won Nobel Prize Award. After that, barulah static drop mercury electrode was first invented by John S. Smith and Bruce N. Whitlock. Sorry, Doktor, salah dia punya kronologi. That's next.
Patutnya kronologi tadi macam mana?
First tu yang Profesor Jaroslav Herofsky tu. Lepas tu dia dah win Nobel Prize. Lepas tu next dia punya development. Lepas tu John L. Smith ni dia develop static drop mercury electrode. Macam tu.
Terbalik lah.
Terbalik. Tersalah ni.
Okay, tak apa.
Sorry.
Okay, teruskan.
Next.
Alright, so how SMDE works, basically it uses a solenoid here, where solenoid driven plunger to control the flow of the mercury. So by activating the solenoid, and then the plunger will be lifted momentarily, and the mercury will flow through the capillary, thus forming a single hanging mercury drop. By activating the solenoid repeatedly, it will produce a series of mercury drops. So this is how SMDE works. Alright, next.
So these are the advantages of SMDE. Firstly, SMDE is a removable mercury electrode surface in which we don't have to clean or polish the solid surface as it is self-removed. It can also easily convert it into an extremely stable HDME for shooting of square wave voltammetry. Besides, SMDE has manual or automatic control of purge time, drop size, drop dispensing, and drop dislodgement, and due to these advantages, it has lower detection limit and higher sensitivity. Next.
The next is disadvantages of SMDE. So the first is it requires mercury reservoir because the mercury flow from a reservoir of mercury to a mercury drop capillary. The second one is regular maintenance of capillary is needed to ensure the capillary forming a single hanging mercury is accurate. And the last one, use of metallic mercury can cause some contamination such as amalgamation, capillary plugging, and air leaks. Next.
SMDE can be used in
Tak dengar.
biological organisms for elemental and tak dengar.
Okay.
Nak saya ulang balik ke? Teruskan.
Yes, ulang balik.
Okay. SMDE ni kita boleh gunakan dalam beberapa analysis lah. Okay, yang pertama trace analysis of toxic metals in drinking water. That analysis of biological system. Organic analysis for elemental and functional group analysis. Determination of pesticide or herbicide residues in foods. Analysis of drugs and pharmaceutical preparations. And lastly, environmental analysis, especially in marine study for characterization and of organic matter and metals interactions. Okay, that's all from us. Thank you.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Okey, grup SMDE, saya ada soalan. Apa beza SMDE dengan DME? Okey, wakil grup ke nak jawab boleh juga. Nazila ke nak jawab? Syah ke? Apa lagi? Zam tadi What is the difference between SMDE and DME? The main difference.
Kalau static tu kita hold sampai habis kita punya analisis. Tapi kalau dropping, dia keep on dropping throughout the analysis.
Okay, good. In term of voltammogram, apa beza dia? Orang lain pula. In term of voltammogram. Kalau DME kan dia keep on dia punya current keep on increasing. Then if we change the drop, okay, dia akan jatuh balik. Then dia start increasing balik kan.
Dia ada stable current.
Okay, siapa nak jawab? Untuk SMDE. How about the voltammogram?
SMDE ada stable surface, Doctor. Compared to
Ada stable surface.
DME, always dropping, so stable surface.
Bukan the size of the drop electrode ke? Berapa beza dia dekat voltammogram tu? Boleh komen berkenaan dengan limiting current. The limiting current. Nak tunjuk kat saya slide yang ada gambar voltammogram pun boleh juga. Then explain. Beza kan voltammogram bagi DME dan SMDE kan?
Voltammogram tu yang graf dia tu kan, Doktor kan?
Yes, graf kita panggil voltammogram.
Dia punya dia punya graf tu yang turun naik tu.
Yes, turun naik macam mana? Explain sikit.
Kok macam Doktor.
Apa beza dengan DME? Saya cakap tadi kan macam mana beza dia? DME keep on dropping. Okay, saya tahu DME keep on dropping, tapi what about the electrode size? Dia become larger and larger then drop by gravity, right? Tapi SMDE adakah drop by gravity? Or we control the drop size and macam mana?
SMDE dia punya size drop tu kita control.
Alright, and then what happened to the voltammogram?
Voltammogram tu dia jadi constant.
Constant, okay? At certain current kan?
Yes.
And then bila tukar drop, dia akan increase balik kan?
Yes.
Then constant balik. That is different. Tengok kat bawah tu, voltammogram tu different dia dengan DME. DME dia akan increase dan slightly bila drop tu jatuh, current pun drop to 0 and increase again kan. Tapi kalau SMDE tengok ada satu level tu dia constant. Sampailah dia tukar drop baru. Faham tak? Faham Okey, ada soalan lain tak pada group SMDE? Ada soalan? Okey, kita teruskan dengan next group.
Okey, sekejap Doktor.
Okey, tak apa, take your time.
Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon everyone. So we are from group 3. We'll be presenting about hanging drop mercury electrode.
Okay, for history of HDME, in 1956, Victor Kemula, a famous Polish chemist, electrochemist and polarographer, conduct multiple study on polarographic techniques and proposed a hanging mercury drop electrode HMDE as the working electrode. After its discovery, research was developed in the field of electroanalytical chemistry and hundreds of papers were published. The HMDE is used as the working electrode for various electroanalytical techniques to study for the mechanism and kinetic of electrochemical reaction, and also for the determination of the inorganic and organic species. This working electrode was developed to overcome the disadvantage of TME. Using his approach, one or two mercury drops falling from the classical TME are collected on miniature spoon and transferred to a small metal contact sealed in a glass or plastic. Next.
Okay, this is components of HDME. Okay, for first components we have nut. The common size of nut we use is 11 times 1, which is made of duralumin. And then the second components we have conical joint. Commonly we use 10 per 18 or 14 per 20 size. Also, and made of Teflon or known as PTFE. And then for third component, we have washer, also made by Teflon. And then we have mercury reservoir made by borosilicate glass. And then for fourth component, we have biconical gasket, which is commonly made by Teflon. And then we have scale sleeve, commonly made by duralumin. And then we have the seventh component. We have scale revolving sleeve, commonly made of duralumin. And then we have set screw. We usually use 2x5 and 5. Next. Okay, for component number 9, we have insulating sleeve. Insulating sleeve, basically, we also often use polyamide. Yes, okay. And then we have component number 9, which is plug and cable. Plug and cable also usually made by nickel plated brass. And then component number 11, we have plugger. Plugger commonly made by stainless steel. And then component number 12, we have micrometer screw made by brass. And then we have socket made by gold plated brass. And then we have bolt, also made by stainless steel. And then also nut, but the different nut from just now. It was made by brass, just now made by duralumin. And then component number 16, it was intermediate joint. It commonly made by polycarbonate. Next. Kejap ya, doktor. Okay, for component 17, we have nozzle for aspirator tubing made by polycarbonate. And then we have stopper made by polyamide. And then we have plug made by gold plated brass. And then we have O-ring. For component number 20, we often use 4x1 mm pipe made by Viton. And then for component 20, we have cap. Okay, next.
Okay, this is some of the feature of HDME, hanging drop mercury electrode. So it has a total length of 240 millimeter with outer diameter of 14 millimeter, and its weight of 52 gram, which a plugger diameter yang macam ada yang part komponen yang saya tunjuk tadi, dengan working length of plugger dia 45 millimeter. Next. Okay, ni ada lagi pitch of thread dia 0.35 mm. And then glass capillary in diameter, glass tubing and capillary length, volume of working mercury, and then its the reproducibility of electrode with surface area with 0.62%.
So next is the application of HDME. So why we use HDME? The reason why we use HDME is because it is an alternative analytical technique for the analysis of trace element with relatively ease and success operation. And it has minimal sample preparation and capable of identifying and quantitating trace components from 10 to the power of -5 to 10 to the power of -9 molar concentration. So where can we apply HDME? So it can be applied in any qualitative analysis that can be determined by electrochemical technique. So in various fields, as for example, stress analysis by stripping voltammetry, linear scan voltammetry, or the study of complex equilibria in aqueous solution. So moving on, how HDME works. So one drop is for 1 voltammogram. The entire stripping voltammetry experiment is performed on 1 mercury drop, meaning that one experiment will get 1 result of voltammogram. Then drop dislodge, control size of drop will be dislodged, and the last step is new drop dispense. New drop will be supplied with the same control size. Okay, for the application of HDME, how to set up HDME. So usually the electrode delivered to a customer is assembled and filled with mercury. But for changing the capillary, the electrode must be reassembled. For that purpose, first the assembling configuration must be selected. Then initially the plunger should be raised to its upper position with a scaled revolving sleeve and both threads of the intermediate joint left loose. Next, move the plunger to its lowest position. Subsequently, tighten firmly in the upper inner and lower outer thread of the intermediate joint.
Okay, next how to fill in the hanging drop mercury electron. First, using overflow procedure by using intermediate joint to allow the initial filling of electron. Then remove the stopper and suction with water aspirator applied to the nozzle. Then hold the electrode vertically, immerse the capillary in mercury pool. Next. Okay, then we proceed with electrode is filled with mercury through intermediate joint when the plunger is raised above lower gasket and turning counterclockwise the scale sleeve. Then when the mercury level is raised, move the plunger and shut off the suction. And lastly, put the stopper. Next. Sebelum. Lagi. Okay. Next step, refilling the electrode with mercury. For refilling the electrode with mercury, as in the figure, immerse its capillary tip in mercury pool and turn counterclockwise the scale revolving sleeve while holding the electrode vertically. Next. Okay. For testing the electrode, it recommended to test the electrode under the cyclic volumetric condition. So before proceed with the research purpose. So and this is the cyclic voltammogram. Each voltammogram was recorded at a fresh mercury drop formed by turning clockwise the scale revolving sleeve by 180 degrees.
For the advantages of HDME, low consumption of mercury because kita boleh control drops of mercury, produce a partial mercury drops of control geometry and surface area at the end of a capillary. Fresh metallic surface is readily formed by simply producing a new drops. Lagi satu advantages adalah electrode assembly consists of a capillary which allow to obtain drops of reproducible area rapidly. Next. Disadvantage of HDME are static surface are more prone to surface absorption phenomenon, release contaminated drops and regular maintenance of capillary. Okay, sekian, terima kasih.
Okay, terima kasih kepada grup SMDE. Alright, ada soalan daripada ni ahli kelas, geng-geng yang lain. Saya ada soalan untuk grup SMDE. Katakan saya punya nitrogen gas habis, boleh tak saya nak guna SMDE? Hello? Boleh tak?
Sekejap Doktor, tengah bincang.
Tengah bincang. Okey, tidak. Saya dah pernah sebut dalam kelas sebelum ni.
Boleh.
Macam mana boleh tu? Okey, sebelum ni saya dah cakap untuk control pressure bagi mercury electrode, okay, kita ada dia punya mercury storage tu kan, ada capillary sebagainya. Kita nak control the pressure is kita menggunakan nitrogen gas, alright? So nitrogen gas tu yang mainkan peranan untuk kita nak push mercury sebagai drop electrode, and then kita nak dropkan dia jatuh, kita nak bagi dia hanging, kita nak bagi dia jatuh. Kalau kita pakai DME, tak ada masalah kalau nitrogen tak ada. Okay, dia keep on dropping. Kalau SMDE, kita nak control juga. Kita nak bagi dia static kan. Tapi kalau tak ada nitrogen gas, macam mana kita nak control pressure? Tak boleh lah. Sebab nitrogen gas ada dua function, ingat tak? Yang pertama untuk apa? Apa ingat lagi? Yang pertama, nitrogen gas guna untuk apa?
Untuk purging.
Purging kan? Okay, saya jawab Farah Okay, untuk purging, kita nak remove all the oxygen dalam sel tu, dalam kita punya buffer solution kan, dalam kita punya analyte kita masukkan tadi, kita nak buang semua oksigen. Function yang kedua ialah kita nak jadikan dia pressure. Okay, dalam ketong gas kan keluarkan pressure kan, gas tu mengalir ke kita mengalirkan dia ke electrode tu, ke electrode container tu, dia bagi pressure kan. Pressure tu yang tolak mercury tu ke bawah, dan kita boleh control dengan kita punya valve lah, okay, untuk stop and open or close the valve kan. Tapi kalau tak ada pressure pada nitrogen, tak boleh nak tolak the mercury tu untuk kita nak bagi hanging ke, nak bagi control size ke untuk SMDE, tak boleh. So kalau tak ada nitrogen, kita tak boleh guna mercury, hanging mercury drop electrode. In fact, tak boleh nak analyze pun sebab tak boleh nak push kan. Alright. Soalan saya seterusnya, apa beza HMDE dengan SMDE? Hanging dengan static, apa beza dia?
SDME dia guna time low ppm range. Kalau DME dia guna apa?
SMDE dan HMDE.
HMDE dia apa ni? One drop je untuk 1 voltammogram. Kalau apa tadi? SMDE 2 Betul.
2.
Dia punya graf dekat apa ni? Voltammogram tu.
Betul.
Kalau HMDE 1 drop.
Mana satu analisis guna 2 drop macam tu. Betul ke?
Kalau HMDE 1.
Ataupun okay, HMDE memang kita setiap per analisis kita guna 1 drop lah, okay. Cuma soalan saya, SMDE tadi 2 drop ke? Ataupun drop tu dia ada timing dia? Dia bukan tak specifically SMDE 2 drop kan? Dia ada timing dia kan? For the size kan? Okay, betul lah. Maknanya untuk SMDE kita guna one drop tu yang kita hanging tu per analysis kan, kita tengok what is the direction. Okay. Tapi kalau drop mercury electrode dan juga static mercury drop electrode, dia memang bertukar-tukar dia punya drop. Kalau drop mercury electrode, dia keep on dropping based on gravity. Kalau SMDE, we control the size kan, static size, okay, and then the drop change again. Okay. Tapi kalau SMDE, that the same drop tu for the whole analysis, and then kita tukar drop baru untuk analisis seterusnya. Okay, okay, faham tak untuk DME, SMDE dan juga HMDE? Faham tak perbezaan dia? Guys, faham tak? Ataupun korang ada soalan untuk grup SMDE lagi? Nida faham tak, Nida? Okay. Lee Chan Yu, faham tak Chan Yu?
Faham doktor.
Nazila Al-Jeffrey, faham tak?
Faham, doktor.
Okay, so Anis Hadibah, faham tak?
Faham, doktor.
Okay. Nak check ni korang betul-betul ke tidur ke apa kan? Nak panggil seorang lah. Hamka ada Hamka?
Ada doktor. Faham.
Faham Okay, bagus Hamka. Jektiswari, tengah raya lagi ke?
Faham doktor.
Faham Okay. So kalau faham, okey lah. Kita ada berapa grup lagi? Aisyah akan present?
Ada lagi 3.
3 kan? So hari ni 3. Then next class kita 3 lagi lah. So hari ni 6 lah 3 sebab kita nak fahamkan DME, SMDE dan juga HMDE. Dan so Khamis nanti kita dengar tajuk apa lagi ada?
RDE.
Apa?
RDE.
Okay, rotating electrode. Okay, lagi?
Lepas tu pulse and differential pulse. Lepas tu dengan square wave.
Fluorography kan? Okay. So kita jumpa Khamis nantilah. Ni saya record untuk presentation korang ni. Nanti saya upload lah dalam e-learning. Okay. So ada soalan lagi tak nak tanya? Tak ada? Okay, good. Okay, tak apalah, faham lah tu kan. Jangan lupa 1 Disember lock tarikh tu, 1 Disember pagi. Next week kan? Betul tak?
Betul.
Okay, 1 Disember kita akan adakan online global classroom bertajuk, tajuk dia dah tukar sikit ni. Voltammetry, a practical beginner guide. Okay. Panelis dia saya, Dr. Jose Hernandez Santos daripada Universiti Brunei Darussalam, Dr. Nur Rahmat Syukri daripada Universiti Sains Malaysia dan juga Dr. Tana Lachmi daripada UTM juga, postdoctoral. Okay. So, lock tarikh tu, ingat, letak reminder, for my class, wajib datang, okay, dia ada attendance. And then, kalau tak ada apa-apa lagi, kita jumpa Khamis nanti. Assalamualaikum dan selamat petang. Bye.
Terima kasih doktor.
Sama-sama.
Thank you doktor.
Okay, welcome.
Thank you, doktor.